Have you ever just paused for a moment and really thought about the internet? I don't just mean what's on it, but what it actually is. We use this incredible thing every single day, but what's really happening in those quiet little moments between you clicking something and, well, it appearing on your screen? Let's gently pull back that curtain and just take a look.
You know, it feels completely instant, almost like magic, right? But in that tiny split second, a request from your device starts this pretty amazing journey. And it's not just one big leap, it's a whole series of really carefully coordinated steps.
And that journey, it takes place across the internet, a system so unbelievably vast and complex, it's kind of a miracle that it works so flawlessly. So, to manage all that complexity, the engineers who built it came up with a really smart idea.
They decided to break the problem down. Instead of tackling one giant, impossible task, they created a set of smaller, much more manageable tasks. They organized them in what we call layers, and each layer has just one specific job to do, and it relies completely on the layer right below it to help it get that job done.
To make this idea feel a little less abstract, let's use an analogy. Think about the last time you took a flight. That whole process is super complex, but you don't have to think about all of it at once, right? And that's because it's all broken down into these layers of service. What's so interesting here is how each of these steps provides a service to the one right above it. The people at the gate, they don't fly the plane. They just have to trust that the pilots will. The person who sells you the ticket doesn't worry about your bags. They trust the baggage handlers. See? Each layer just does its one job, trusting the layers below. The internet works in pretty much the exact same way.
So let's actually follow a little piece of your data on its journey. We're going to start at the very top, inside the application you're using, and then we'll work our way all the way down to the physical wires and radio waves that carry everything.
Okay, so this is the layer we're all familiar with. This is your web browser, your email, your favorite game. It's the part of the whole process that understands what you, the user, actually want to do. Like, get me that web page or send this message.
So, the application layer creates the raw data that you want to send out. If you're sending an email, this is literally the body of the email. For now, let's just call this piece of data a message. So, okay, we have our content. Now, how do we get it ready for delivery?
Well, that brings us to the transport layer. Its whole job is to act like an internal postal service right inside your computer. It takes that message from your application and gets it all prepped for its long journey. A lot of the time, that means breaking a big message into smaller, more manageable chunks.
It packages your message into something we call a segment. This is kind of like taking that letter you wrote and putting it into an inter-office envelope. You add a little bit of info, like which specific application on the other computer should get this data.
Right below the transport layer is the network layer. Now, if the transport layer was like the inter-office mail, this is the global postal service. Its one and only job is to get your data from your computer to the destination computer, no matter where on Earth it is.
And to do that, it takes our little segment and puts it inside yet another package, this one called a datagram. And on this outer package, it writes the full mailing address for the whole world to see, the IP address of your computer and the IP address of the destination. And finally, we get down to the bottom layers. The link and physical layers handle the real nitty-gritty of that final step, actually moving the data across a single physical link. So this could be over an Ethernet cable to your router, or maybe over a Wi-Fi signal. They take that datagram and they package it one last time into what's called a frame for this one specific hop. So did you catch the pattern there? At each step, each layer took the information from the layer above it and just wrapped it in a new package, adding its own special delivery instructions. This really simple but powerful idea, it has a name.
It's called encapsulation. And honestly, the best way to think about it is like a set of those Russian nesting dolls. We start with our original message, and at each step down, we place it inside a new container with a new label, or what we call a header.
So, it all starts right here, with the original message from your application.
Then, the transport layer wraps it, adding its own header to create what we call a segment. Next up, the network layer wraps that entire segment, adding the IP address header to create a datagram. And then finally, the link layer adds its header for that local journey, creating the final frame that gets sent out over the wire. It's really a brilliant way to prepare a simple request for what's actually a pretty complex journey.
So when you put it all together, what you really have isn't chaos. Not at all. It's a system of quiet, elegant cooperation.
And once that final frame arrives where it's going, the entire process just happens in reverse. The link layer unwraps it and passes the datagram up. The network layer unwraps that and passes the segment up. The transport layer unwraps that. And finally, your original, untouched message is delivered to the correct application.
Perfect.
So the next time you click a link, maybe just for a second, think about that incredible journey. It's a nice little reminder that the most complex systems we build often work because of a simple, elegant idea. Just a quiet agreement where every part knows its role and plays it perfectly.